We now talk about spherical coordinates. So we're still in three-dimensional space. Now there's three coordinates x, y, z, or in cylindrical, which we looked at, there were three coordinates, and they were um, r, theta, and z. Since spherical coordinates are also used to describe three-dimensional space, there are three coordinates. So theta, rho, and phi. So I think theta, you know the name of, so maybe I don't even need to write that one. This one is, let's draw that a little better, write that the first time a little better. This one is called rho, R-H-O. It's kind of a rounded shaped P, and it is the Greek equivalent of the Latin R. And then this one here is phi. It is the Greek equivalent of the Latin or the Roman F. Now, these three coordinates. This is not the order that we typically write in, not in the typical order for integration. We'll get to that in a moment, but this is the best order to learn them in. So sorry if it's not the usual order, but I think it's just helpful to let's build up slowly. So first of all, what about theta? Theta is the easiest because, well, theta is the same as it's the same theta from cylindrical and thus polar, because really cylindrical just borrowed from polar and thus polar coordinates. Okay, so nothing new, nothing different there. So for example, the conversion x is equal to r cosine theta, y is equal to r sine theta. Both of those still apply. Okay, so we're done with theta. We move on to rho already. So what about rho? What can we say about that? Rho, well, just instead of saying what rho is first, let me say what rho is not. Okay, so rho is not the same as r. Okay, so r, like as in that r from polar coordinates, not the same. Okay, so instead, rho is the straight line distance of the point that you're talking about from the origin. Here's another thing. We've seen that the polar coordinate r can be negative, but rho cannot be. So rho has to be greater than or equal to 0, always. Okay, so there's another difference. Because we're talking about the distance that the point xyz is from the origin, like the straight line distance, then we have x squared plus y squared plus z squared is equal to rho squared. Okay, let's practice what's going on by doing the following. For the point x, y, z equals 3, 4, 7, I'd like to find theta from cylindrical coordinates or polar coordinates, find r from cylindrical or polar coordinates, and since rho is new, let's also find rho as well. Okay, so first of all, there are technically lots of possible answers for theta and r, but I think the most natural one is to recall that tangent of theta is equal to y over x, so 4 over 3. And so one possible answer for theta could be the arctangent of 4/3. Then what about the value of r? Well, remembering that r squared is equal to x squared plus y squared, then r is found by taking the square root of 3 squared plus 4 squared, so root 25, which is equal to 5. What about the value of rho? So from the fact that rho squared is x squared plus y squared plus z squared, rho itself should be root 3 squared plus 4 squared plus 7 squared. You could leave it like that, but I just wanted to type this into a calculator, see what we get. This is approximately 8.6. A couple comments are in order. I think, first of all, the value of theta. This does not use at all the fact that z is equal to 7. Yeah, it was up here that z is 7. Didn't get used at all. Same deal here. Getting the number 5 didn't use at all the fact that the height of the point was 7. However, when finding row, the number 7 was in fact used. Okay, time for the interactive question. So write the point. XYZ equals 1, 2, 3. And by finding cylindrical coordinates, that is, find z, r, and theta. It doesn't matter really the order, just whatever you just mark that clearly, and then find what rho is in spherical coordinates. And perhaps the more important part of this question isn't just this computation, but answer the following thing, and you may want to consider using your example. Then, using geometric language, explain how rho in spherical coordinates, the rho from spherical coordinates, is different from the r that comes from cylindrical coordinates.